Look closely, right here. You are staring directly at one of the most advanced optical illusions on planet Earth. This glasswing butterfly isn't made of glass. It is using nanoscale physics to bend light, hiding in plain sight from the Canopy's deadliest assassins. But surviving the daylight in this high-altitude cloud forest is only half the battle, because when the freezing fog rolls in at twilight, 1,000,000 tiny bodies must sacrifice themselves to build a living, breathing fortress or die trying. Welcome to a world suspended between earth and sky. It is 5 a.m., high within a fog-draped canopy. Hundreds of feet above the forest floor, a hidden micro-ecosystem thrives among dripping orchids and moisture-swollen bromeliads. In this untouched wilderness, survival is dictated by ancient circadian rhythms. As the blue light of dawn washes over the branches, nocturnal hunters retreat and the daytime world awakens. Emerging from the damp moss is a creature that seems to defy the very categorization of insects. This is the velvet worm, or Onychophora. It is an ancient survivor, a biological bridge between segmented worms and modern arthropods. Unlike the hard-shelled beetles that share this canopy, the velvet worm lacks a rigid skeleton. Instead, it moves using a fascinating mechanism of hydraulic locomotion. By manipulating the hydrostatic pressure within its fluid-filled body cavity, it extends and contracts its unjointed lobopods, allowing it to ripple silently over the wet terrain. It is highly sensitive to desiccation, and as the morning light approaches, it must find a dark, damp crevice to avoid drying out. Nearby, clinging perfectly flat against a lichen-covered branch, a bark mantis lies in wait. This predator is a master of evolutionary camouflage. Its exoskeleton perfectly mimics the peeling bark and green liverworts of its surroundings. As it prepares to strike, we can observe the sheer brilliance of its exoskeletal articulation. The joints of its raptorial forelegs are lined with microscopic, sensory hairs that detect the faintest vibrations in the wood. When a leaf mimic katydid gingerly steps onto the branch, the mantis rotates its triangular head. Its massive compound eyes, composed of thousands of individual ommatidia, grant it an exceptionally wide field of binocular vision, allowing it to calculate the precise distance to its target. By 7:30 in the morning, the bright, overcast sky brings a soft, diffused daylight to the canopy. The morning vitality has truly begun. Deep within the dripping orchids, a marvel of optical physics reveals itself. The glasswing butterfly rests delicately on a waxy petal. To the naked eye, its wings appear made of fragile glass, revealing the blurred jungle background directly through their tissue. But this is not glass. It is a highly advanced defense mechanism born from structural biology. The transparent panels of its wings are coated with millions of nanoscale pillars. These microscopic structures are smaller than the wavelength of visible light. They create a gradual transition of the refractive index between the surrounding air and the chitin of the wing. By eliminating abrupt optical boundaries, they completely absorb and scatter light, preventing any glare that might alert a hungry bird or a sharp-eyed jumping spider. This is stealth technology perfected by millions of years of natural selection. As the butterfly extends its long, coiled proboscis to drink from a pool of condensation, it shares the branch with a much more formidable resident. A massive, solitary bullet, ant marches aggressively along the slippery wood, named for the agonizing pain of its venomous sting, which ranks at the very top of the Schmidt sting pain index. The bullet ant is an apex scavenger. Its venom contains ponerotoxin, a paralyzing neurotoxic peptide that aggressively blocks sodium ion channels in the central nervous system, ensuring any attacker experiences a wave of relentless, burning agony. It sweeps its long geniculate antennae back and forth, reading a complex landscape of highly volatile chemical gradients that we cannot even begin to perceive. It is searching for protein to carry back to its colony, acting as a vital component in the intricate trophic cascade that governs this high-altitude canopy ecosystem, moving energy from the lowest producers up to the apex predators. Not all giants here are hunters. Plodding heavily through a pile of decaying bromeliad leaves is the brilliant metallic golden scarab beetle. Its mirror-like exoskeleton gleams in the morning mist, a result of complex structural coloration, where microscopic layers of chitin reflect specific wavelengths of light. This heavy armored beetle serves as a crucial recycler, accelerating the decomposition process. By breaking down the tough, rotting plant matter that accumulates in the forks of the branches, it returns locked nutrients like nitrogen and phosphorus back to the epiphytic roots, sustaining the very flora that shelters it. As the morning progresses toward 11:30, the atmosphere shifts. The high-altitude winds die down, and a flat, stagnant midday light penetrates the gray, overcast sky. The temperature rises rapidly, turning the humid canopy into a sweltering greenhouse. For the arthropods, this intense heat presents a deadly physiological challenge. Insects do not possess lungs or a closed circulatory system to efficiently transport oxygen. They rely on a passive respiratory system. They breathe through a network of branching tracheal tubes connected to the outside world by small muscular valves called spiracles, arrayed along the sides of their abdomens. This biological limitation restricts their maximum size and makes them highly susceptible to fatal water loss. To prevent their internal fluids from evaporating and their cellular proteins from denaturing, the inhabitants must seek immediate shelter. A colossal male Hercules beetle, one of the heaviest insects on the planet, wedges his massive bulk beneath a rotting bark shelf. Resting completely motionless, he utilizes active ventilation, slowly and rhythmically, pumping his armored abdomen. This maximizes the airflow through his spiracles to cool his core body temperature from the inside out. Deep inside a dry, crumbling tree hollow, a giant, red-kneed tarantula sprawls flat across a thick bed of moisture barrier silk. By extending its legs fully, the spider maximizes its surface area to dissipate metabolic heat, slowing its heart rate and entering a deep state of physiological torpor to conserve precious moisture. It is during this midday stillness that the first signs of an approaching storm begin to manifest. Beneath a dense canopy of overlapping bromeliad roots, small groups of army ants begin to gather in the shadows. Unlike other ant species, army ants do not dig permanent underground colonies or build nests of mud and chewed wood. They are entirely nomadic, cycling between migratory and stationary phases dictated by the reproductive cycle of their queen. To protect their queen and their fragile larvae from the elements, they must construct a temporary home using the only material they have in absolute abundance, their own bodies. But the construction will have to wait for the cooling air of dusk. By 2:30 in the afternoon, the intense heat begins to break. The fading diffused daylight casts warm, muted tones across the mist. The canopy stirs with renewed micromovement. A spiny orb weaver, characterized by the hard, defensive spikes protruding from its abdomen, waits patiently in the center of its elaborate silken snare. Spider silk is an evolutionary miracle, a complex protein called fibroin, extruded as a liquid that instantly polymerizes into a solid thread due to the sheer mechanical stress of being pulled through the spinnerets. Pound for pound, it possesses a tensile strength greater than high-grade steel, yet remains incredibly elastic. When a microscopic gnat blunders into the sticky capture threads, the spider detects the precise frequency of the vibration. In a blur of motion, it rushes forward, using its specialized hind legs to pull broad sheets of fresh silk over the struggling prey, mummifying it alive in a matter of seconds. Lower down on the damp mahogany trunk, the velvet worm has emerged early to hunt. It is a slow, soft-bodied creature, seemingly vulnerable, yet it wields a weapon of terrifying biochemical efficiency. Flanking its mouth are two specialized appendages called oral papillae. When it senses the movement of a small cricket, the worm violently contracts its internal muscles, firing twin streams of biological glue from these turrets. This proteinaceous slime can be shot over impressive distances and oscillates in mid-air, forming a wide net. Upon contact with the air and the frantic mechanical struggles of the prey, the glue rapidly hardens, effectively cementing the victim to the bark, allowing the slow-moving worm to inject digestive enzymes and feed at its leisure. As the clock strikes 4 in the afternoon, the silence is shattered by the deep, hollow drumming of hard keratin striking resonant wood. Two colossal male Hercules beetles have crossed paths. Their gigantic thoracic horns, lined with sensitive yellow hairs, are not weapons of piercing, but rather tools of immense biomechanical leverage. The two titans lock their pincers together. With a deafening grating and squealing of polished exoskeletons, they shove each other with incredible hydraulic force generated by the massive muscles housed within their thoraxes. The goal is not to kill the rival, but to out-leverage him, exploiting the physics of fulcrums to pry his sharp tarsal claws from the bark and drop him into the endless mist below. The struggle sends high-frequency vibrations echoing through the branches, alerting a true nightmare of the canopy, the tarantula hawk wasp. With bright, warning orange wings, a clear signal of aposematic coloring, and a body built for specialized combat, she lands aggressively at the edge of the red-kneed tarantula's dark tree hollow. The wasp does not seek to eat the giant spider herself. She is a parasitoid. She must paralyze the tarantula with a venom so potent it permanently targets voltage-gated ion channels, completely disabling the spider's nervous system without stopping its heart. She will then drag the living, paralyzed giant into a burrow and lay a single egg upon its abdomen, providing a fresh, living larder for her developing larva. The tarantula rears back, baring its massive fangs and hissing loudly by stridulating its mouth parts, initiating a desperate clash for survival. At 5:15 in the evening, the high-altitude sun dips low and the twilight transition begins. A dramatic drop in temperature causes a heavy, suffocating blanket of glowing orange and dusty blue fog to roll violently through the branches. The day is over. The true rulers of this micro-jungle now awaken. Over 1 million army ants mobilize. They stream out from the deep crevices, funneling into massive, unstoppable columns that flow like a dark red river over the thick, mossy roots. This entire legion operates without a single central commander, functioning instead as a highly efficient superorganism. Their collective intelligence is dictated entirely by a complex language of chemical pheromones. As the lead workers rush forward, they drag their stingers along the bark, laying down highly volatile chemical trails composed of specific hydrocarbon blends. The concentration, decay rate, and geometry of these invisible paths tell the millions of workers behind them exactly where to go, where to hunt, and where to build. As the darkness deepens, the insects of the day seek refuge. The glasswing butterfly finds the underside of a broad, waxy leaf. It folds its transparent wings tightly together and locks its microscopic hook-like tarsal claws securely into the plant fibers. This incredible locking mechanism requires absolutely zero muscular effort to maintain, relying entirely on passive mechanical resistance. This allows the butterfly to fall into a deep, immobile sleep, as heavy beads of freezing condensation begin to accumulate on its delicate frame. By 6 o'clock in the evening, the army ants begin their most awe-inspiring architectural feat. Converging at the fork of a massive branch, the workers begin to build the night bivouac. They frantically crawl over one another, reaching out into the empty void. Using their specialized tarsal claws, which act like microscopic carabiners and strong mandibles, they hook onto the legs of their sisters. They lock firmly together in midair to form strong biological chains. These living ropes dangle down, serving as the foundational scaffolding for an incredible feat of biological architecture. Thousands upon thousands of ants pour over the sides, thickening the outer shell to create an interlocking bivouac. The larger, heavier soldiers, equipped with massive ice-pick mandibles, aggressively push their way into the dense cluster. They embed themselves at critical junctions, acting as load-bearing pillars to provide crucial structural integrity to the nest. Through constant tactile communication, furiously drumming their antennae against their neighbors, they continuously adjust their grips, dynamically distributing the immense weight and tensile stress perfectly across the structure. Deep within the dark, hollow center of this living sphere, the colossal queen army ant is safely enveloped. Around her, thousands of nurse ants delicately carry precious bundles of white larvae. To survive the freezing night air, the workers making up the innermost walls begin to shiver their bodies continuously. By rapidly contracting and relaxing their thoracic flight muscles, they generate vital metabolic heat, acting as biological radiators. They can elevate the internal temperature of the bivouac by several degrees, maintaining a perfect, climate-controlled internal environment for the vulnerable brood. At 6:45, the final workers arrive. The massive, throbbing outer shell of the bivouac seals its final opening at the top. The outermost layer is composed entirely of the lethal soldier ants, facing strictly outward into the thick blue fog, with their massive mandibles wide open, ready to defend the sleeping colony against any nocturnal terror. The tightly packed bodies of the workers act as a perfect water-repellent biological roof, utilizing the hydrophobic properties of their chitin to effortlessly shed the heavy, freezing drops of canopy condensation. As the clock strikes 7 o'clock in the evening, absolute pitch blackness claims the high-altitude jungle. The heavy midnight fog completely swallows the hanging Spanish moss and the slippery branches, reducing the world to nothing but gray vapor and oppressive silence. In this deep night, every creature, from the heavily armored Hercules beetle to the incredibly fragile Glasswing Butterfly, finds its rest. The grand, brutal cycle of life in the canopy is paused, suspended in the dark void, waiting for the first light of dawn to trigger the eternal struggle once more. The army ants are safe tonight, inside their living fortress of bodies. But they aren't the only master architects in the Arthropod wilds. Down on the dark jungle floor, a trapdoor spider has engineered a pressurized hydraulic vault that defies gravity. To see how she constructs this underground death trap, click the video on your screen right now. I'll see you down there.